Hello guys, welcome back to the Universe of Tech Hub. In this tutorial, we will learn about trees. What is tree? First, we need to understand what is tree. Tree is a non-sequential or non-linear data structure. It is also called as non-sequential data structures. It represents the relationship between the nodes and collection of entities called nodes. The collection of entities is called as nodes. Every nodes are connected by edges. Topmost node is root node. It's a origin of tree. It's a connection between two nodes is called as edge or link. First, we need to understand what is tree. Tree is a hierarchical data structure that consists of nodes and connected by edges. We already know about what is nodes and what is edge. Nodes is a collection of entities, and what is edges means it's a connection between two nodes is called as edges. It's a non-linear data structure and also called as non-sequential data structure that resembles a tree in a nature with a root node at the top and various levels of child nodes below it. Each node can have a zero or more child nodes, and relationships between nodes create a parent-child hierarchy. This is what is tree. Next, we move on to the terminologies of tree. We see in this diagram, this is the root node. B and C are the parent to root A, and D and E are the child of parent B. G and F are the child of parent C. So, this is the subtree. B, D, E are the subtree. C, G, F are the subtree of A. B and C are the subtree of A. So, the last nodes, the level 4 are the leaf nodes. Node which have no childs is called as leaf nodes. This is the height of the tree. The number of edges present in the longest part to the mentioned node. This is the height of the tree. The height of the tree is nothing but a height of root node. This is all about tree terminologies. Next we move on to the characteristics of tree. Before we go into characteristics of tree, we need to understand what is parent, what is subtree, what is child, what is siblings, what is leaf node, root and edges, like that. It's a connection between two nodes is called as edges. We already know about what is edges. Collection of entities called as nodes. So, what is child? Child is which has a node child or children. All the node except root node has the child node. So we need to understand what is child. Node is a belongs to the same parent is called as a siblings. These are the D and E are the siblings of B. So again and G and F are the siblings of C. Node which have no child is called as a leaf node. K, L, M, N, O, P are the leaf node. Also called as external node or terminal node. A node which have at least one child is called as a internal node. This is the internal node H, I, J. Next we move on to the characteristics of trees. In the characteristics of tree, every tree has a root node. This is the first characteristics of a tree. Every tree has a root node. If n nodes, if n minus 1 edges. If n number of nodes minus n minus 1 edges. For example, n is equal to 11. 11 minus 1 is equals to 10 edges. So, 10 edges are in these trees. Every child has one parent, multiple child. This is also characteristics of tree. Tree is a recursive data structure. Degree of a node nothing but a total number of children. This is the fourth characteristics. The highest child of a node is the degree of the tree. This is all about characteristics of tree. Next one is levels. What is levels? Levels refers to the depth of a nodes within the tree. This is the level 0, level 1, level 2, level 3, level 4. These are the levels refers to the depth of a nodes within the tree. This is the root node, right? A is the root node. This is the root level 0. The node Nodes are direct children of a root node or at the level 1. So, this is all about levels. Next, we need to know about the height of the tree. The number of edges present in the longest paths to that mentioned node. It is called as height of the tree. Height of a tree is nothing but a height of a root node. Next, we move on to the what are the types of trees? There are mainly four types in trees. First one is binary tree. Second one is binary search trees. Third one is Abel tree. Next one is B trees. First, what is binary tree? We need to understand a binary tree is a where each node has at most two children, left and right. It is also called as binary tree. Next one is binary search tree. A binary tree where the left child contains the values less than the parent node and the right child is contains values greater than the parent node. And next we will see about the examples of binary trees, binary search trees, and average trees and B trees. Next is Abel trees, a self-balancing binary search tree where the difference in heights between the left and right subtree is at most one. This is all about Abel tree. And next about is B trees, is a self-balancing tree data structure that maintains a sorted data and allows for efficient insertion, deletion, and search operation. This is all about B trees. Types of trees. Next, we are going to about examples of types of trees. First one is binary tree, right? The binary tree. I need to construct a binary tree. Binary tree is a tree structure where each node has at most two children, typically referred to as the left and right child. Binary trees are useful for representing a hierarchical data structure. Data. I take one example to showing these are all the nodes. I need to construct. I need to link with each node using edges or links. So, is the root node. I want to give a name. So, like 1, 2. This is the construction of binary tree. What binary tree tells? Binary tree is a tree structures where each node has at most two children. Typically is referred to as left and right child. Binary trees are useful for representing a hierarchical data. This is all about binary tree. Next, we are going to type, that is binary search tree. I'm going to construct binary search tree. See about how to construct binary search tree. Before going to construct binary search tree, we need to understand first what is binary search tree. The binary search tree is a type of binary tree where the left subtree of a node contains only a nodes with a values less than the node's value. The right subtree of a node is contains only a nodes with the values is greater than the node's value. This is all about binary search tree. The next, both left and right subtrees must also be binary search tree. BSTs enable efficient and searching, insertion and deletion operation with the operations like that. Next, need to construct binary search tree. How to construct binary search tree is in some nodes. We need to connect using a links or edges. This is the rule. Binary search tree says so. The left node is the 8. So, in the left subtree of a node is contains only a nodes with the value is less than the node's value. So, I want to take 3 as the left subtree and 10 as the right subtree because the right subtree of a node is contains only a nodes with values greater than the node's value. So, I want to take 10. 10 as the right subtree. Next, this is the parent. 3 is the parent node. The 3 parent left subtree is less than the 3, right? So I need to take 1. I need to take 6 as the right subtree of 3 and this is the 10 right subtree. So I want to take greater the 10. So I want to take 14 or 11, 12 like that. I want to take sub 14. Next, I move on to the 6th node. This is the left subtree, right? In the left subtree's value is less than the 6th. So I need to take 4. This is the right subtree of 6th node. So I want to take the value is greater than the 6. So 7. This is the left subtree of 14. So I want to take 12 or 13, 12. I want to take 13. This is all about how to construct a binary search tree. Binary search tree. Next we move on to the next type. AVL tree. It's an AVL tree is a self-balancing binary search tree where the heights of the two child subtrees of any node differ by at most 1. If this condition is not met, the rotation, singles or double, are performed to balance the tree. In the searching, insertion, deletion like that, I have shown one examples to how to construct a AVL tree. This is the example. I want to take one node. Next, I connect it using a links edges. Take 30 as the root node. 30 as the root node. In the left subtree is the less than the root node, that is 20. Right subtree is greater than the root node. I want to take 40. Again, place the same as 20th parent node. 10 is less than the 20. So I want to take left subtree as 10. 50 as the subtree of this AVL tree. Next we move on to the next type, that is B tree. To understand what is B tree. About what is B tree? B tree is a generalization of binary search tree where each node has where a node can have a more than 2 children. B trees are typically used in database and file system. The first property is nodes can have a multiple keys. Next one is all leaf nodes are at the same depth. Next one is internal nodes are used for indexing and making search, insertion, deletion efficient. This is all about the B tree. Let's see how to construct B tree. First I am taking one node. The parent node as to connect with link using a link. What tree? All about the B tree. Nothing but a balanced tree. The AVL tree is a self-balancing binary search tree. It is a balanced search tree. This is the example of B trees. Next, we move on to the tree types. There are 5 types in binary tree types. First one is fully complete tree. Next one is complete binary tree. Next one is perfect binary tree. Next one is balanced binary tree. Fifth one is pathological binary tree. The first one is fully binary tree. What is fully binary tree? Fully binary tree as every node is containing 2 child. Leaf node contains a 0 node. It is called as fully binary tree or fully complete tree. Or full binary tree is every node contains a 2 child. Leaf node contains a 0 node. It is called as fully binary tree. Next one is complete binary tree. According to complete binary tree, we need to check all the levels filled with nodes except last node. This is called as complete binary tree. We move on to the next one is perfect binary tree. What is perfect binary tree? Types of binary tree in which all the internal nodes contain two children and all leaf nodes are the presence at the same level. It is a perfect binary tree. Between full binary tree and perfect binary tree is all internal nodes have two children. In the full binary tree, in the perfect binary tree, all internal nodes of the two children. In the full binary tree, leaf nodes in any level, leaf node in minus in leaf node in same level. Next one is balanced binary tree. What is balanced binary tree? Height of the tree will be less than 1 or equal to 1. That is the balanced binary tree. This is the balanced binary tree. Next one is the pathological binary tree. What is pathological binary tree? Is every parent node can contain only one child node. It is called as pathological binary tree. This is all about binary tree types. We move on to the visualization of binary tree types. First one is fully complete tree. Second one is complete binary tree. Third one is perfect binary tree. Fourth one is balanced binary tree. Fifth one is pathological binary tree. We know about how to construct binary tree types. We move on to the full complete tree, right? A, B, C, D, E, F, G. We need to construct full binary tree. This is the full binary tree. What is full binary tree says? Every node contain a two child. B and C are the parent node. D and E are the child node of the B. Are the child node of the B. F and G are the child node of C. This is the full binary tree. Next we move on to the complete binary tree. Complete binary tree. 1, 2, 3, 4, 5, 6. To the perfect binary tree. Example of perfect binary tree. This one is the in perfect binary tree in which every internal node has exactly two child nodes and all leaf nodes are at the same level. This is the perfect binary tree. Next one is balanced binary tree. It shows the balanced binary tree. This is the unbalanced binary tree. One is pathological binary tree. Also called as degenerate binary tree. Pathological tree. What it say? A degenerate or pathological tree is the tree having a single child, either a left or right. This is all about uh, types of binary search tree operation. First, we need to know about what are the properties of binary search tree. The first property is the left subtree of a node is contains only a nodes with key contains lesser than nodes key. Next is the left subtree of a node is contains only a nodes. A key contains greater than the nodes key. This is the second property. And the third property is left and right subtree each must also be a binary search tree. Move on to the operations of binary search tree. The first operation is search operation. Next one is insertion operation. Third one is deletion operation. Fourth one is traversal operation. Fifth one is finding a minimum and maximum operation. These are all the operations of binary search tree. Three properties in binary search tree. The first one is the left subtree of a node is contains only nodes with the key contains lesser than the nodes key. The next property is the left subtree of a node contains the only nodes with the keys contain a greater than the nodes key. Then third property is the left and right subtree each must also be a binary search tree. This is the properties of binary search tree. Next, we need to know about operations of binary search tree. The first operation, search operation. Next one is insertion. Next one is deletion. The next one is traversal. And next one is finding a minimum and maximum. This is all about binary search tree operations. Before we go into operation, we need to know about difference between the general tree and binary tree. Before going to operations of binary search tree, we need to know about general tree and versus binary tree difference. What is the difference between general tree and binary tree is the number of children in general tree is unlimited per node. In the binary tree, the maximum of 2 children per node. Next is Methods in pre-order, post-order, and level order in general tree. The binary tree, pre-order, in-order, post-order, and level order in the binary tree. Use cases in general tree is a file system, organizational structures like that. In binary tree, searching, sorting, heap structures like that. And a parent and child relationship in any node can have a multiple children. In a general tree, in binary tree, a node has a left and right child. This is all about the general tree. Binary tree. We're going to perform operations of binary tree. Insert 21, second one 10, third one is 50, the fourth node is 5, fifth node is 20. This is the perform insertion operation in binary search tree. We will see about how to perform insertion operation. Next one is 30. 30 is less than 50, right? So we need to insert in left subtree of 50. Next 70. 70 is greater than 50. So in right subtree we need to insert next 3 and 7. 3 is less than 5. So I need to insert in left. Next 7. 7 is greater than 5. So I need to insert in right. This is all about insertion operation. So next is the root node. This is the left subtree. This is the right subtree. These are all the parents. These are all the nodes. Child nodes. These are all the child node of 5. Next, we need to delete 5. I need to delete 7. We will see how to delete the nodes in a binary search tree. This is all about delete operation. Next, we move on to the find. I need to find 30. This is the 30. Find means search operation. First print 3, 10, 20, 21, 30. It's all about traversing. It traverses each node and print the node. First it prints 3, next 10, 20, 21, 30, 50. Small to large. This is all about the binary search tree operations. I hope you understood what concepts of binary tree and trees, what is tree, characteristics of tree, and properties of trees, and also types of trees, and also binary search trees types, and how to construct types of trees. This is all about trees concept. If you like this video, please don't forget to subscribe, like and share and comment in this video.